Hi, today we're gonna work out the example of a double glazed window. The window separates the inside and the outside of a house. Although it provides good insulation, there's still a rate of heat loss through the window. First we draw a sketch of the situation with the two glass plates and the air gap in between. And we state the thermal conductivity over here and the distance between the plates as L. We assume that the temperature at 1 is equal to the temperature in the inside, so 20 degrees Celsius. At the other side, we assume that a temperature at T is 4 is equal to the T of outside, so 0 degrees Celsius. And we also assume that this problem is steady state. For this problem, we will calculate the rate of heat loss, which is given by the heat flux times the area. We note that the temperature at X is equal to T1 minus T2 minus T1 over L12 times X plus T1. And we call this equation 1. We arrive this equation towards X to obtain the following equation. T2 minus T1 over L12. We multiply both sides by lambda minus lambda 12 to obtain this equation. Times minus lambda 12. Next we apply Fourier's law, which says that the heat flux is equal to lambda 12 times dt over dx. To find that T2 minus T1 over L12 is equal to the minus of the heat flux over lambda 12, and we apply the following rule to find that minus the rate of heat loss over lambda 12 times A, and we call this equation 2. Next we put equation 2 in equation 1, and we will find that Tx is equal to minus Fq over lambda 12 times A times X plus T1. Next we use the boundary condition that says that T at X is L12 is equal to T2. And we fill this in, we can find that T2 is equal to minus Fq over lambda 12 times A times L12 plus T1. When we rewrite this equation, we can find that T2 minus T1 is equal to the minus rate of heat loss over lambda 12 times A times L12, and we call this equation 4. As you can see, this equation applies only for the distance 1 to 2. We can derive the equation of the temperature for the air gap and for the other glass plate as well in the following steps. Try it yourself and we'll come back to you in a second. In the next step, we add up equation 4, 5 and 6. First, from equation 4 we find that T2 minus T1 plus equation 5, T3 minus T2 plus from equation 6 T4 minus T3 is equal to minus phi q over lambda 12 times A times L12 minus phi q over lambda 23 times A times L23 minus phi q over lambda 34 times A times L34. And we know that these terms cancel each other out. T2 and T3. So when we rewrite this equation, we find that T4 minus T1 is equal to all these terms, but we also take minus phi q over alpha out. So we find these terms that L12 over lambda 12 plus L23 over lambda 23 plus L34 over lambda 34. Note that T4 minus T1 is the driving force, Fq over A is the flow, so this is the resistance. In this exercise we want to know what the rate of heat loss is, so we have to rewrite this equation to Fq is equal to 1 over this term, so L12 over lambda 12 plus L23 over lambda 23 plus L34 over lambda 34 times A times minus T4 minus T1. Now next, if you fill in all the numbers, you will find that Fq is equal to 571.42 joule per second. Note that joule per second is equal to watt, so we find that the rate of heat loss is equal to 571.42 watt. Thanks for your attention and good luck with the following exercises.